Hi guys, today we're doing how many apples can you put into the basket. So we have some apples in a basket that can carry up to 5,000 units of weight. Given an integer array called weight, where weight at I is the weight of the ith apple, they want us to return the maximum number of apples we can put in the basket. So in example 1, we're given this input array where weight equals these weights, and we would output 4 because all 4 apples can be carried by the basket since their sum of weights is 1450, which is less than 5,000. Yeah, less than 5,000. So we can carry all of these in the basket. In example 2, we're given this input array, and we would output 5 because the sum of weights of the 6 apples exceeds 5,000. So we can choose any of the 5, or any 5 of these. So without it exceeding 5,000 units of weight. So basically in this problem, I think the easiest way to do this is going to be to sort the array, because if we sort it, then we can access the ones that weigh the least in order from least to most, because we want to return the maximum number of apples we can put in the basket. And so to get the maximum number of apples, we want the apples with the least weight, because that way we can get as many as we can without exceeding the weight. So first we're going to sort the array, and then we're just going to basically go through from the beginning to the end in sorted order, and until the weight is like we're going to continuously add the weights up and like continuously go through until we are past 5,000, until we cannot add any more without exceeding 5,000, right? And then we're going to return how many apples we were able to get. So let's start by sorting our input array. So let's also copy and paste this so we can see what's going on. So then sorted of this would be 100, 150, 200, and 1,000, right? So, and let's also give these indices. So 0, 1, 2, and 3. Okay. So yeah, so we're gonna sort the array. So we're gonna arrays.sort, wait. And then once it's sorted, we're gonna get this basically is our new array. And then we want to keep track of a few things here. We want to keep track of the number of units of weight we are currently at, because we don't want it to exceed 5,000. So we'll say units is 0. And then also the number of apples that we have, since that's what we're returning here. So apples. Okay. And then we're just going to loop through the array then, one by one, and add up the weights until we get to something that would exceed 5,000. So for I is 0, I is less than dot length, I plus plus. And then we need to do a check to make sure that it would not exceed 5,000. So if units plus weight at I is less than or equal to 5,000, because our current unit is, or our current units are the number of units of weight that we currently have, and so we need to check not just this, but this plus weight at I, which is the current one that we're at, because if our current weight plus the new weight would exceed 5,000, then we don't want to add it, because that's going to be too much, right? So we only want to do it if those two combined are less than 5,000. So if this is the case, then we can go ahead and add this. And then we also want to increment apples. And then at the end, we're just going to return the total. Oops. Yeah, so we're just going to do this for every single apple, and then we're going to return the total. No. We're going to return the apples. Yeah, so there we go. Sorry, sometimes when I talk and I type at the same time, I start typing what I'm saying instead of what I mean, and then I just get confused. So, okay, so if we walk through this, then basically we are starting I off at 0. Units is 0, apples are 0. So units plus weight at I. Weight at I is going to be 100, because we're currently at I equals 0. So since units is 0, so that's going to be 0 plus 100, which is, 100, which is less than 5,000, so we are going to add it. So then units becomes 100, apples becomes 1, since we increment apples here. Okay, now I is 1. And then units, which is 100, plus weight at I, which is now 150, because weight at I is 1, so then this is going to be 100 plus 150, which is 250, and that is less than 5,000. So we're going to go ahead and add it. So now units is 250 and apples is 2. Then now I is 2, so at I equals 2, the weight at I is 200, so now we can check if 250 plus 200 is going to be 450, which is less than 5,000, so we can go ahead and add these. So then units now becomes 450, apples becomes 3, and I is now 3 because we're in the next iteration. So then now at I equals 3, the weight at I is going to be 1,000. So if units, which is 450, plus weight at I, which is 1,000, that is going to be 1,450, and that is still less than 5,000, so we're good. So we're going to go ahead and add it. So then units is going to plus equal that. So then now units is going to be 1450, and apples is 4. And then now I is 4, and that is greater than the length of the array, so we exit the loop. And then we return apples, which is 4. So that's how that works. Now let's go over the time complexity. So basically, so in the arrays.sort, that is going to be O of n log n, just because of the sorting. And then this is constant. This loop is going to be O of n because basically we are looping through we're visiting every single element inside of our weight array here on average. So, well, worst case, but I guess like it's still proportional to this, right? So we're going to add that, and then so then we get O of n plus O of n log n, which is going to be O of n log n, because down here this is constant, so we don't care about that. So then we get O of n log n, where n is the number of apples in our weight array. Then our space complexity is constant, and that is because we don't have any data structures here, because we just reorder or sort the array in place with arrays.sort. We have some variables here, and that is it. So since we don't have any additional data structures, then our space complexity is constant. And that is it for this problem. Thank you guys for watching, and like and subscribe if you found this helpful. Bye!